Good afternoon. Today, I will present about effects of running time-oriented primary EPL program on computational thinking ability of elementary school students. Here is my contents. I will present about this scenario. Here is an abstract. In this study, we developed and applied the primary educational program language program focused on algorithm running time as an educational method aimed at improving computational thinking of elementary school students. Subsequently, we examined and verified the effectiveness of the developed educational program. The program was developed based on the results of a preliminary demand analysis conducted on 48 elementary school students. The analysis outcomes show that the primary EPL education focused on running time was effective in improving the computational thinking of elementary school students. By using the Korean Vigorous Challenge hosted by the Korean Information Science Education Federation as an assessment tool, educational effects were analyzed through the results of pre- and post-computational thinking assessments. Introduction. In Korea, software education has been widely introduced in line with current trends through the revised curriculum of 2015 and is provided in elementary and middle schools in various approaches. Most elementary schools in Korea currently offer basic programming education through block-based programming language, as these languages provide audiovisual elements that are suitable for the cognitive level of elementary school students and can easily attract their interest. However, assessments on the computational thinking ability, which students develop through the programming learning process, have not been actively conducted thus far. Some of the reasons for this include lack of awareness regarding the importance of computational thinking assessments, absence of assessment tools that are easily accessible to instructors and learners to evaluate computational thinking, and complexity of computational thinking assessment methods. According to the Software Education Operating Guide established in 2015, the goal of software education should be also involve cultivating creative convergence talents, having computational thinking. Therefore, research on improving the computational thinking of students is necessary. Accordingly, this study developed an elementary educational program using learning time-oriented educational programming language to help improve the computational thinking of elementary school students. The program contents was selected based on the preliminary demand analysis results, and 25 students in 4th and 5th grade were selected to verify the effectiveness of the developed educational program. After providing the educational program as an intensive course, we used the Korea Vigorous Challenge 2018 as an assessment tool for evaluating the computational thinking ability to support our proposal of an effective EPL education method that can help improve the computational thinking of learners. EPL is a computer language designed to prevent students from feeling overwhelmed when learning to program. A programming language generally requires learners to spend a large amount of time in grasping basic grammar or structures, causing cognitive burdens. By providing simple structures, the VL is designed to allow young learners and beginners to reduce cognitive burdens and to further their students' interest in programming learning. In this study, the EPL education method was adapted to improve the computational thinking ability of elementary school students by focusing on algorithm running time, in particular, Scratch, which is the most widely used EPL method and has many advantages, was used to implement the proposed educational program. Scratch is a free programming language tool developed by the MIT Media Lab in the US in 2007 as a means of developing the intelligence and creativity of children aged 8 to 16. It is an interpreter-based educational program language that is designed to help young learners develop their creativity habits by continuously repeating the idea, practicing, and sharing processing. The Scratch programming language combines the way children think of algorithm with the built-in logical programming, called blocks, to alleviate the difficulties presented by the existing text input method for understanding structures and grammar. Further, it supports using various multimedia like graphs, sounds, etc. Owing to its small size, the user can easily carry the software and can share the developed program through the website. Hence, this study used the latest Scratch offline editor version 3 to implement the proposed educational program. Algorithm running time refers to the time the algorithm takes to generate an output based on a given input. The performance of an algorithm can be evaluated based on both the running time and the amount of required memory space. However, in most cases, the running time tends to be the most important factor. The analysis result of the algorithm running time is referred to as a time complexity, which enables algorithm performance assessment by counting the number of computational operations required to execute the algorithm. As the number of computational operations in the algorithm primarily varies on the algorithm running time, the algorithm running time should be carefully handled to enable efficient problem solving. In this study, to allow students to easily compare the running time and to simplify the education process by teaching students according to their capability levels, the number of computational operations is counted directly in the Scratch program. Further, the education program was designed to encourage students to try various approaches to find an algorithm that minimizes the running time. The phrase computational thinking first emerged in the computer science education community in 2006 after Wing defined its thinking like a computer scientist when tackling a program to be solved. In Korea, through the Software Education Operation Guide established in 2015, the Ministry of Education also generalized the use of the computational thinking term by defining and emphasizing the goal of software education as cultivating creative convergence talents having computational thinking. Computational thinking can be referred to as a procedural thinking ability for solving problems through abstraction and automation. Hence, developing computational thinking has become the main goal of software education. In this study, our main goal was to promote the development of student computational thinking through the process of comparing and analyzing the algorithm running time needed to solve a given problem and to find a more efficient algorithm by using EPL Scratch. Previous studies. A study by Yoon analyzed the effects of EPL on programming abilities, computational thinking, and problem solving in terms of programming education. In the study, among various EPLs, Scratch was used to provide programming language education, which helped students improve their programming abilities, computational thinking, and problem solving skills while achieving a high student satisfaction. In a study LIM, an algorithm-based teaching and learning method was developed to enhance computational thinking. In the study, computational thinking skills were improved through the process of solving problems by using algorithm-based teaching and by learning methods to solve computer science problems in the information subject. Yang has developed and applied an educational program that was focused on analyzing the running time of sorting and searching algorithm for elementary school students. By analyzing the educational effects of the program, he determined the education that featured comparing and analyzing algorithm running time has provided a positive effects on improving the logical thinking of elementary school students. Further, it was suggested that running time can be an effective programming education topic to help improve thinking skills. As described previously, to promote and enhance computational thinking, which is an essential goal of a software education, various students have been actively conducted in the education field by using the Scratch and Python programming language. In these studies, the algorithm running time was selected as a tool for improving the computational thinking of students. To present the concept of an algorithm running time to students, the concept was simplified in accordance with the student's cognitive level. Further, after conducting a demand analysis by reflecting the difficulty of the topic among various EPLs, Scratch, which is the students are familiar with, was selected as the educational tool. Finally, we verified the effectiveness of the development educational program on improving the computational thinking of the elementary school student. Now I'm going to talk about research methods. First, I make a null hypothesis. No difference exists between the learner's pre- and post-computational thinking after participating in an algorithm running time-oriented primary EPL education. Alternative hypothesis is like this. A differences exist between the learner's pre- and post-computational thinking after participating in algorithm running time-oriented primary EPL education. My study subject. In this study, 25 volunteers were selected among the applicants for the education donation program conducted by Jeju National University. This table 1 summarizes the grade and gender of the participants. As shown in Table 2, the educational program was developed in accordance with the ADDIE model process of Dick and Carey, which is the most widely used instructional design model. I make this educational program like this sequence: analysis, design, development, implement, and evaluation. Table 3 shows the list of teaching methods that the students mainly experience in their software education. According to the survey result, physical computing was the most common teaching method, followed EPL, unplugged, and computer language. Table 4 shows the result of the survey on whether the student understood the software education concept of algorithm. The result shows that more than 80% of the students discovered the term algorithm through software education and understood its meaning. As shown in Table 5, 96% of the students answered that algorithm education is essential in software education. First, the software education methods that students most often experience are physical computing, EPL, and unplugged, while the computer language method is rarely experienced. As the students are rather unfamiliar to the algorithm running time topic, among the tools that students frequently used, like Scratch, which is one of the EPL, and enable convenient comparative analysis of running time, was selected as the tool for the software education. Second, most students answered that they have previously encountered algorithm through the software education, and that they understood the concept to some extent. Additionally, the students agreed that learning about algorithm running time is necessary. We aimed to improve the computational thinking of students by allowing them, through Scratch, to analyze and compare various algorithms by solving the same problem and finding out which algorithm is most efficient. Here is my educational program design. We constructed a running time-oriented primary EPL educational contents. Table 6 summarized the learning theme of the class sessions. This figure 1 is a part of the developed content, then introduced the concept of algorithm running time by using the topic finding the greatest common divisor. It also described the method of measuring running time. Next page is a part of the developed content that compares the algorithm running time, number of operations, after serving the same topics with two different programs. As for the experiment tool, we used the assessment sheets from the Korea Vibres Challenge 2018, hosted by the Korea Information Science Educational Federation, to evaluate to computational thinking improvement. For this study, in particular, the Vigorous Challenge Group 3 assessment sheet, designed for 5th and 6th graders, were selected based on the age and level of the student participating in the experiment. Additionally, pre- and post-test sheets were used to measure the change in computational thinking. A total of 25 students in 1st and 5th grade were selected as a sample group for the study. The educational program consists of 7 sessions per day for 6 days and included both lecture and practice sessions. The actual classes were conducted as 18 minutes blocks in the form of intensive course to maximize the learning effectiveness. The Vibras Challenge, which is a computational thinking assessment tool, was used to evaluate pre- and post-test results, which were then used to analyze the effectiveness of our educational program. Table 7 is a summary of the experimental design. Results. Since the sample size was 25 students, a normality test was conducted to verify that the computational thinking test result of experiment group shows normality. The Shapiro wheel test was used for the normality test, and the results are shown in Table 8. From the normality test, a p-value of 0.282 was obtained. The null hypothesis was accepted to assume that the normality was secured. As the computational thinking assessment results were verified to show the normality through the Shapiro wheel test, a paired t-test was used for comparison of pre- and post results. As in show Table 9, in a paired t-test, the average score increased by 1.08 from pre-test score of 5.28 to post-test score was 6.32, and the p-value of 0.002 was obtained, indicating a statistical significance of the improvement of the computational thinking. Before analyzing the Vibras challenge result, we conducted a Shapiro wheel test to verify that the test result of the experiment group show a normal distribution. Assuming the results show a normality, a paired t-test was conducted to compare the pre- and post-test result. According to the paired t-test result, a higher computational thinking average score was observed in the post t-test, and a statistically significant improvement was obtained in the p-value. Therefore, the experiment in the study successfully managed to prove the running time-oriented primary (EPL) education can improve the computational thinking ability of elementary school students, and that the topic of algorithm running time can be implemented as a useful software education topic for elementary school students. Here is my conclusions. In this study, we attempt to analyze the effects of algorithm running time-oriented primary EPL education on the computational thinking of elementary school students. To achieve this, we developed an educational program based on a preliminary demand analysis by following the ADDIE model process. Educational program was provided to students, as a 6-day intense course, and changes in computational thinking were evaluated through the pre and the post-test results. Based on this result, the proposed educational program was found to be effective in enhancing the computational thinking ability of the elementary school student. Students show high satisfaction with the educational program by trying various approaches in the process of comparing running time and improving their programming skills. Based on this finding, we can conclude that the algorithm running time comparison and analysis subject is useful in developing the computational thinking of learners, which is the main goal of software education. However, generalizing this study presents some limitations, as the sample size of the experimental group did not exceed 30 participants, which is the minimum number required for a general correlation study. Since the effectiveness of the developed educational program was verified only with the pre and post-test results without having a comparison group, there is a possibility that the correlation of the program effectiveness may not have been clearly expressed in detail. In a follow-up study, we intend to secure a large number of participants and to construct experimental and comparison group to analyze each study result factors more systemically. Thank you for listening. Have a nice day.